All right, so let's get started. So instead of talking about some social science examples, I thought maybe we could think about this in a different context. How many of you have watched crime shows like Law and Order? So if you're like me, you've seen them all. There's Law and Order Special Victims Unit, Law and Order Criminal Intent, a lot of Law and Order, and I think a few others. But what combines or what unites all of these series is that they all focus on a crime that gets brought to court. And we're going to use that as an example to think about type 1 and type 2 errors. All right, so let's say there's a murder and the district attorney that prosecutes the crime brings together all of the evidence. The evidence is eyewitness accounts, the evidence is, various documents, there's character assessments, there's a variety of things. And for the jury, the standard of evidence is met in terms of identifying this person as guilty. So they present their case, the jury comes back with a guilty verdict, the judge says, you're guilty, and that's it. And then there's, as in all Law and Order episodes, a twist. That someone comes along with DNA evidence. So evidence that is far stricter than eyewitness accounts, far stricter than positive IDs. It literally shows the person's DNA wasn't at the scene. So that person gets exonerated. Their guilty verdict gets commuted and they are now not guilty. Now, clearly the jury made a mistake, okay? They committed a certain kind of error, for example. So let's compare that with a different kind of scenario. Let's say a new jury comes in and they've been hearing about all the exonerations that have been happening in terms of that have overturned guilty verdicts. And this particular jury says the only evidence that they will hear are evidence for a crime that involves DNA evidence. That's the only evidence they'll accept. And so the prosecution presents its case. They've got eyewitness accounts, they've got documents, they've got character assessments, they've got all this other stuff. They've even found blood at the scene. But there hasn't been any DNA evidence that basically establishes the guilt of the person on trial. So for that jury, the standard of evidence is not met. And since it's not met, they return a verdict of not guilty. But it's Law and Order, so there's always a twist. And someone comes along and says, hey, we actually found the DNA evidence and the person actually did do it. They're guilty. Okay. So on one hand, we've got a scenario where a person went to jail that shouldn't have. They got exonerated, but it wouldn't have happened if we didn't have the new evidence. In this scenario, we have a situation where a person should have gone to jail but didn't. And so these types of errors are actually very parallel to what is occurring within social science research. When you're doing social science research, we've got an alpha that is establishing the likelihood of error, likelihood of sampling error, and our outcome, we got our test statistic, we get our p-value, and if our p-value is, again, smaller than our alpha, we say that we found statistical significance. But then let's say we think about changing our alpha. We think about making it even smaller, and so small that that p-value is no longer smaller than it. And that could give us an outcome of not significant. And so the difference between significant and non-significant in this example, in terms of outcomes of hypothesis tests, is essentially a type 1 error. It's an error that occurs when a significant difference that's occurring is actually not significant in the population. Now, the other scenario is you find no evidence of statistical significance, your p-value is way too large, larger than your alpha, it's not significant. But then we test it, let's say, with a different alpha. An alpha that's a little more liberal, a little more less stringent, and then we return a significant outcome. The difference between this and this is an example of a type 2 error. So another way to think about this is you against the truth. And in this graphic, you can see you against the truth, where your findings, where your null hypothesis is true and your null hypothesis is false, as again, representing your findings being intersected with the truth, what is actually happening in the population. So you've got your null hypothesis in reality is actually true, and that's what you found? Correct. Yay. But if, let's say, your hypothesis is actually true and you didn't find that, that is a type 1 error, okay? And in the other example, your null hypothesis is false. There was actually a significant difference, you didn't find it. In your findings, that's a type 2 error. But let's say there was no significant difference to be found in reality, and that would be correct. Now, thinking about this, one of the things that becomes really important is first knowing that the truth may be out there, but we are very, very unlikely to actually find it. And the second thing is that our only defense is to be transparent about our criteria and the implications of using that criteria. So if you're using an alpha of 0.05 and the differences you find are significant according to that alpha, if someone comes along with the DNA evidence that essentially exonerates the significant finding, I know, the metaphor doesn't really make sense there, but you know what I mean. You can still fall back on this difference, even if it was sampling error met this criteria. There was a 0.05 chance that I made a type 1 error and it happened, but I'm transparent about my criteria. Alternatively, you find non-significant findings and you actually find, yes, this could have been significant, but this actually is significant in the population. I committed a type 2 error. And that again happens all the time in terms of the fact that sometimes we find lack of evidence of differences that actually exist. But our best defense, bringing it back to the legal metaphor, is to be clear about the evidence that we used. My standard was 0.05, this didn't meet it, so perhaps next time you should collect a larger sample, you should think about classifying your variables differently, whatever. The point is that it didn't meet the standard. Now, type 2 error is captured with beta. Again, it's another probability estimate, but we don't necessarily work with it as much as we work with alpha. So, I hope this short video helps clarify some of the type 1, type 2 error questions that you may have. We'll continue to wrestle with these as we move on with hypothesis testing. Take care.